In this part 2 video, I will go through the complete process of doing a 2-layer stack of liftoff metallizations, including doing a precision alignment and using the virtual aligner feature to check and fine-tune the alignment prior to exposing. And I will also go over some more details of the machine and a few of the special writing modes and special features that the machine has. I'm using the plasma asher to clean this little chip to get it clean before I spin the photoresist on it. Using AZ1512 photoresist and using recipe number 3 on the spinner, which should give me about 1.2 microns of resist. Recipe 3 is 4000 RPM for 60 seconds with a ramp rate of 1000 RPM per second. I put it on the hot plate, which is set at 95 degrees for 4 minutes. Came out pretty blotchy, but oh well. The chip is roughly 25 by 20 millimeters. It's good to know the rough size of your substrate so that the centering operation will go quicker. And if it's rectangular, you should know which direction it's oriented. I have it so the long direction is going left to right. Close the door gently and hit the little button. When it stops blinking, you're ready to get started. First, open up Focus Assist. Then use the thumb wheel on the mouse to get that in focus manually. Then turn off Focus Assist. And try the icon for automatic focusing. Looks good. The green bar went all the way to the right. Now under the Wafers pull-down menu, click the current Wafer Properties. This is a rectangular substrate, so I'm putting the correct sizes in there. Then hit the icon to start the automatic centering operation. It goes back and forth between the DLP focus and the laser while it's looking for the edges. It's looking for 4 different edges. When that's done and the green bar is all the way to the right, hit OK. Now I'm going to go switch it to times 20. It takes a minute to switch over to the other lens. Once you see that it's over to the new lens, then you're going to hit focus again to focus with the new lens. Make sure you don't hit focus while the lenses are still in motion. Wait till it's fixed. Okay, now it's in the times 20 lens. And now you hit the automatic focus icon and it's going to focus automatically. Went all the way green, so it looks good. Now click the prepare pattern step. This is still from a previous user, so I'm going to select that and delete it. Now I go up under tools to the job list builder. Click the ... and look for the pattern I want. Then select it and then hit open. So I filled it in with, it's a rectangle. I want to fill in a 7 by 7 millimeter area with 2.2 millimeter spacing between centers. And that gives me a field of 9, 3 by 3. Then you hit add to position list. Now those 9 jobs appear in the prepare pattern section here. So I selected all 9 jobs so I can enter the same quality and the same resolution for all 9 jobs. I set the quality for all of them at high, and I set the resolution for all of them at 0.6 microns. And with all of them checked still, I went into advanced exposure options and I tried best for the real-time focus correct. It's probably not necessary, but I thought I'd give it a try. And it's always a good idea to make sure that invert exposure is not checked. Then I click OK. So now I want to make changes to each of the individual ones so I can give each one a different dose correction factor. I want to have 9 different doses. So what I'm going to do is the upper left is going to be 1, then it's going to be 1.1. Next one will be 1.2, and so on until the 9th box. I'm going to have that as 1.8. Now I'm just checking to make sure all the dose correction factors are what I want. Everything looks good. I went to the expose step and pulled down the options so I can check the focus lock options. I have the first 4 boxes checked and it's on DLP real-time correction, so I'm going to hit OK. I hit the green light go button to start writing. It says autofocus has not been run. I know that it's actually in focus, so I'm going to hit yes. If you weren't sure though, you could go back to the align wafer step and refocus using the 20 times lens, which is what we're going to be writing with. So there's actually 9 different jobs. Each job is at a different dose, so it's going to do each job one at a time. Watch the time remaining clock on the right. When it gets down to 0, you'll see on the bottom it says tidying up. In a few seconds, it'll say finished. Then you can go ahead and open up the chamber and take out your part. I took it out and I'm going to develop it for 40 seconds in MF319 developer. When I'm done with that, I take it over, put it in a dish of water, rinse off my tweezers, pick it up again, rinse it one more time, lay it on the wiper and blow it dry. So then I mounted it on a plate so I can e-beam evaporate some chromium onto it. And here it is with chromium on it. So then I did a lift off of the chromium, just stick it in acetone, it only takes a few minutes. And then after a good rinsing and a quick 15-second plasma etch in the oxygen plasma etcher, I'm ready to start spinning again. Same recipe as last time, recipe number 3, 4,000 RPM for 60 seconds with a ramp rate of 1,000 RPM per second. And the same 95 degrees for 4 minutes bake. So here it is with the resist spun over the previous patterns. It spun out a lot more evenly this time for some reason. I'm going to load it in again in the same orientation as last time. We don't need to center it this time because all we're going to be doing is aligning to one of the patterns that's already on there. So what I did was focus it. Then I switched over to the ×3 lens, which has a wider field of view. Got it in focus again. And then under the microscope pull down menu, I put it into wide field viewer so I can make a mosaic image. Once I have that mosaic image, that'll give me kind of a roadmap of this little area of the chip where the patterns are. This makes sense for a small chip like this, but you wouldn't want to do that for a full wafer. For a full wafer, the easier way to do it would be to center the wafer and then enter the X and Y coordinates for alignment marks that you know are way out at the edge of the wafer, and then hunt around for the alignment marks one by one that way. So now I have this completed mosaic image, which I can use as a roadmap as I'm looking for alignment marks later. Then I put the microscope on ×10 and just started looking around closely at the different patterns that I made, trying to decide which one I like. I discovered that the first 3 doses that I did look a little bit underexposed in some of the smallest features. So I'm going to pick one of the patterns from the center row to do the alignment over. So you should always use the lens that you're actually going to be exposing at when you're doing the alignment, when you're finding the coordinates. So now I'm here switched over to the 20 times lens. I need to first focus, so I'll do that with the focus assist first. Once that looks good, I'll try the automatic focus. It's doing that with no problem, so now I'm going to start looking for the coordinates of the alignment marks. I should go into a little more detail on alignment marks. Your alignment marks should be located near the extremities of the pattern you will be aligning to in subsequent alignment steps. It's a good idea to have a minimum of 4 alignment marks, although you may get by with only 2 or 3. It can't hurt to have extra alignment marks in case one is lost due to underexposure or a defect in the resist. Put the alignment marks on easy to remember coordinates because you will need to enter those coordinates during the alignment step. If your pattern allows, it's convenient to have an alignment mark in the center at the 0, 0 coordinates. which will allow a quick one-point centering operation, which will speed up finding other alignment marks at the perimeter of the wafer or chip. A simple round dot works great as an alignment mark on this machine. Other shapes are usually okay provided you can see the entire alignment mark in the microscope's field of view. If you make a dot, don't make it too small, because a dot, because of proximity effect, needs a little bit higher dose usually than larger features. So you don't want to make your dot so small that you risk having it not come out during a subsequent liftoff step. For this demonstration, I used 6 micron dots. When I did the liftoff, they actually came out to more like 5 microns due to a slight underexposure. So make sure that your dots are large enough that they're going to survive any subsequent liftoff step. I put a larger circle around the actual alignment marks, and those large circles help you to find the alignment mark while you're searching for them on a lower powered microscope lens. So here's one of my actual alignment marks. I used the wide field viewer to jump close to this, and I double click on the center of the dot to get the dot in the center. Remember that while you're searching for your alignment marks and marking them, you want to be using the lens that you're going to be writing with. So I'm using the 20x lens because I'll be writing at 0.6 micron resolution. So just by double clicking the dot, I got it roughly centered, but I want to get much more accurate than that. I'm going to be showing you the Bullseye Method, which is an automatic way to find the exact center of that dot. However, you could do it manually. You would basically just put the crosshairs as close as you can manually in the center of the dot or whatever your alignment mark is. You would first use the ×4 to zoom in and then get it as close as you can manually. You can use the arrow keys on the keyboard to move the substrate in very tiny increments to get the crosshairs centered as carefully as possible. But I'm going to show you this Bullseye method, which is a nice automatic way to do it. I first click on the Bullseye icon, and then I go up to the Alignment pull-down menu and click on Bullseye Options. This is where you give it some details about your alignment mark to help it find it. The marker size was listed at 10 microns, but I'm going to switch that to 6 microns. And then I'm going to click where it says Display Marker Identification. That gives you a little circle that you can see. And then I'm also going to click Marker is brighter than background, because these are chromium marks on a silicon background. Then I click the ×4 digital zoom to zoom in so I can see what's going on better. The red circle and the red cross is what the machine is identifying as an alignment mark. It's a good way to verify that the machine is seeing what you're seeing. Then I click the bullseye icon, and now it will automatically center it. You don't want to jiggle the keyboard or the machine while it's doing the centering operation because it's moving in very tiny submicron increments. If you look at the match quality green bar, it's showing only partially to the right. I think if I had selected 5 microns instead of 6 microns, it would have gone all the way to the right. I think this dot is more like 5 microns because it was slightly underexposed. Now I go up to the alignment pull-down menu again, click center wafer, and then this window shows up. This is where you would click marker 1 so that the machine knows where you have found the first alignment mark. You can do these in whatever order you want, just as long as you keep track of which one is which. You click the green arrow for marker 1, and then now you see the little homing guy is there. That means that this position has been marked. You can always click this green guy again later, and it will jump back to the same exact position. If you made a mistake here, you just click the red X and then start over. So now I went over to the second alignment mark. I'm going to go through the same process. Go to the ×4, click the bullseye icon. It centers it. Make sure you're not jiggling anything while it's doing this operation. Then go up again to the alignment pull-down menu, center wafer, and you're going to mark this as marker number 2. Then I'm going to use the little map I made using the wide field viewer to jump over to the third alignment marker. At ×4, sometimes you're not going to see the alignment mark in there. So I uncheck the ×4 digital zoom. Then I click on the alignment mark. I'm focusing again just to make sure it's crisp. Then I'll go to times 4. Do the bullseye again. Let it center it. Go to the pull down menu and mark this as the 3rd mark. Then one more time, I'm going to do it for the 4th mark. Click the times 4. Click the bullseye. Let it center it. Then go up to the alignment menu. Go to center wafer and mark that as the 4th marker. So now it knows the locations of all 4 alignment marks. I know it's difficult to see here, but now is when you come in and enter the marker expected positions. So this is where you positioned your alignment markers on the design that you used to write the previous pattern. So you enter the coordinates for X and Y for each marker. Make sure you do them in the same order as where you found the markers. My markers are plus or minus 0.8 millimeters from center. Since you have to type these in manually, it's nice to have them at nice, easy to remember coordinates. When you're designing your previous pattern and laying out the alignment marks, make sure that the alignment marks are actually where you think they are. If you click on it, you can go to you can check the parameters for it and it'll tell you the exact coordinate of it. If you happen to have snap to grid turned off and you put the alignment mark where you think it looked right, it may not actually be right exactly where you want it. Okay, now I've finished typing in the coordinates for the marker expected positions where they were on the design. And now it's time to do the actual alignment operation. But before you do that, look in this correct for section. You have to make sure that offset, slope, and rotation are selected. It doesn't automatically check rotation, so you need to put a check mark in rotation before you do the actual alignment operation. So again, make sure offset, slope, and rotation are checked. So here I am checking rotation. Once you check rotation, another option comes up for stretch and shear. Stretch and shear, normally you would only use those if the previous pattern was drawn on another machine. If you're using this machine, you shouldn't need to use that. But if your previous pattern was done by e-beam lithography or maybe on the Heidelberg, you might want to check stretch and shear. And what it'll do is digitally stretch everything to match up with the alignment marks that you have in case there's slightly different spacing than where they're supposed to be. If you look down here in the bottom, everything is at 0. Once we do the alignment, you'll see all of those numbers will change. The little box to the right is what you push to do the actual alignment. Always make sure though that before you hit that offset, slope, and rotation are checked. You'll see all those numbers at the bottom of 0. Once you check that and it does the alignment, all of those numbers will change. So I'll go ahead and click that alignment icon and you'll see all of these numbers on the bottom will change. Then make sure you hit OK in the lower right when you're all done with this alignment step. Now the alignment operation is done. So I'm going to click on Prepare Pattern to start preparing the pattern that we're going to write that's going to be aligned to the alignment marks from the previous pattern. So I click the plus sign, select 1, because I'm just making one job. With 1 selected, I go down to the ... and look through the folders and see which pattern I want to write. It's this one right here, so I select that. By the way, I made two separate patterns with two different names. But normally you would do this with, you would design it as one pattern with two levels. And then when it asks for layer, you would put L2 instead of L1. But I'm using two separate designs, and they're both on L1. So I'm changing the resolution to 0.6 microns. And for the quality, I'm going to try high. Then I'm going to click Advanced Features, make sure everything looks good in here. For some reason I clicked off Enable Best Stitching, but I should have left that on. But we'll see what happens. And then hit OK. So there's the pattern, and we're almost ready to write, but we need to check the focus lock options. That all looks good, so I hit OK. Now I want to check to make sure the dose is correct. I entered 140. Now, as just to check to make sure that the alignment is perfect, I'm going to go to Exposure Options and click Only Prepare Data Do Not Expose. That way I can render the pattern so that I can use the virtual aligner feature. Then you hit the Go button like you're going to start writing, and then this warning pops up, warning you that you're just rendering an image right now. Go ahead and click Yes. This usually goes really fast because it's not actually writing, it's just doing the data crunching to render the image. Another nice thing about doing this is that you get an estimate of how long it's going to take to write when you actually do the real write. When it says finished at the bottom, the rendering job has been done. Now go back to the first Align Wafers step so you get the microscope image. Then under the Alignment pull-down menu, click on Virtual Mask Aligner and then click on Show Pattern to be Exposed. Now you get this purple image that's been rendered of the pattern that you're going to write superimposed on top of the microscope image. You can see that it's a hair off, maybe a micron off. This can sometimes happen due to temperature drift in the chamber, like if you kind of rushed through and you didn't let the interior of the chamber warm up back to its normal regulated temperature. For a slight drift like that, though, it doesn't affect the rotation usually. So all you might have to do is, using this virtual mask aligner, you can shift the image until it lines up perfectly. You can go all over the place on the wafer, and right now the mask and the image are locked together. So you can check it in various places and see how things line up. If I decide I want to change the alignment, I go up and click on Virtual Aligner and then go down and click Release Mask from Wafer. So now the mask and the wafer aren't locked together anymore. So now if I make tiny movements using the arrow keys on the keyboard, I can get the two images to line up perfectly. Once I'm happy with that, I can go up and uncheck Release Mask from Wafer. Once that is unchecked, then the mask and the wafer will be locked together again. Then you can move around again if you want to, wherever you want. In case you want to jump around to the different alignment marks and see if they all look good. Once you're happy with the alignment, you can go ahead to the Expose step now. Now we're going to be doing the actual exposure. Go to the Exposure Options panel and make sure to uncheck the Only Prepare Data Do Not Expose box. Then hit OK. Then hit the green Go button. If you notice, the pattern is a little bit rotated. That's because the wafer was rotated slightly from the previous pattern job. That's because we aligned for offset, slope, and rotation. If we had forgotten to check the rotation box, the pattern would be aligned based on the center of the pattern, but the rotation would be off. When it's almost done, you'll see down here in the bottom, tidying up. Once it's actually done, it'll say finished. Then you can go ahead and take the sample out of the chamber. Remember not to leave the chamber door open while you're heading over to the wet bench to do your development. Now I'm doing the developing, same as last time, 40 seconds. Water rinse. I like to rinse off the tweezers in between picking it up out of the water again. And then I'll rinse it one more time. Developer's kind of soapy and you always want to rinse it off really well to make sure you don't leave any residue from the developer on there. Now I'm going to do an evaporation of chrome gold on top of this. The gold will give a nice contrast to the previous chrome evaporation. I actually aligned to two of these patterns. You can just barely make it out. The second one and the second one down in the left column and the third one down in the right column. And here it is with the chrome gold coating on it. You can just barely make out the patterns. When I say chrome gold, that's a gold film with a chromium adhesion layer. After doing the liftoff of the chrome gold coating, you can see that the alignments came out really nice for both of the patterns that I made alignments to. You can usually expect about 0.5 micron accuracy for the alignment if you're careful about it. This last group of pictures was taken with a 50 times lens on our Nikon microscope. I want to go back to this picture to point out something that you should know when you're designing your masks. In SIF format, if you draw a line as a line, if it's called a line, it always ends with a radius at the ends. So I drew these as lines, and you can see there's a radius on the end. It's not really what I wanted. If you want a line to end with a square end, draw it as a rectangle, as a polygon. Don't draw it as a line. Anytime you draw it, if it's called a line, it's going to end with a radius, whether you like it or not. And if you export a pattern that you designed as lines from another program, even if that program had specified that the lines end square, when it converts to SIF, it will turn it back into a radius at the end. So just remember, for any lines that you want to end with a square end in SIF format, always draw them as polygons, as long skinny rectangles, rather than as quote-unquote lines. Now I'm going to go over some of the different writing modes. All the work I've been showing you so far is using normal as the exposure mode. However, there are some other exposure modes that you may want to use for some special purposes. A couple of these are ways to get around problems you might have with stitching errors. Stitching errors are slight misalignments between skinny patterns which run through two or more separate write fields. They have made great strides with the reduction of stitching errors in the latest software version though, so these aren't used as often as before. For most work, normal works fine. Generally, if you want to reduce stitching errors, increase the quality from normal to high, or even to super if you don't mind the additional time it will take to write. But now I'll go over some of these other writing modes. Vector multiple objects. What this mode does is to write groups of small features in a more intelligent fashion. Rather than writing in an arbitrary grid pattern, it selects groups of small features and writes them in a way which avoids having any small features fall on the border where two write fields meet. This is great if you are doing large arrays of tiny features. Any features that are larger than about 2/3 of the write field will still be written the normal way. Any features smaller than about 2/3 of the write field will be isolated and written within the center of a write field. So this is great if you're writing something like an array of tiny dots and you just want to make sure that none of the dots fall at the interface of two write fields. It'll make sure that none of the dots get misshapen. Sometimes if you have sparsely spaced small features, this can actually save you some writing time because all it's going to do is go over and put a write field around each of the small features, writing them one at a time. If it was just an arbitrary grid pattern, you might have a small feature that falls at the cross of 4 write fields, and so it would actually take 4 write fields to write the pattern that could have been written with just 1 write field. To decide if this vector multiple objects writing mode works well for what you're doing, you need to know the size of the individual features that you're writing, and then you need to know the size of the write field for the lens that you'll be writing with. There's a laminated card next to the machine that has the size of the write fields for the various lenses. However, those numbers will change a little depending on the quality that you pick. If you pick a higher quality, the size of the usable part of the write field gets a little bit smaller. So that's it for vector multiple objects. The next one down is vector single object. It's very similar to the multiple objects one. However, it's designed to work with larger objects that are maybe 2/3 the size of the right field with the objects centered in the right field in a more intelligent manner. And again, with this write mode, you need to know the size of your objects to know whether this makes sense to use this mode. And then you need to know the size of the write field for the lens that you're going to be writing with. So check the laminated card that's next to the machine and it'll give you a rough idea of the size of the write field for the lens that you're going to use. Any objects that are larger than a write field will still be written with an arbitrary grid pattern like the normal method. That holds true for the vector multiple objects writing mode too. And then one other mode that was designed to help eliminate stitching errors is multipass. What multipass does is write overlapping images at a fraction of the dose. At a multipass of 2, there was a 50% overlap in both X and Y, with each write field only being written at a fraction of the dose so that the stack of overlapping doses winds up being written at the total desired dose. This method was very slow though and is now largely obsolete because it now writes actually as well as or better than what you could do with a multipass of 2 writing in the normal mode with a normal quality setting. And writing in the normal mode with a quality of high writes better than what you could do with a multipass of 3, which had a 66% overlap in both X and Y, which was very slow. So there probably is no longer a good reason to use the very slow multipass writing method anymore when using the current software, which works great now. It's still there though in case somebody wants to use it for some special purpose. Most of you are probably just going to be using normal for the exposure mode, and then you may want to increase the quality from normal to high if you're doing something where a tiny stitching error would cause problems. Like if you're making a waveguide or something like that, and you don't want any slight perturbations in a long skinny line, high or even super might be a good idea. And if you're working with groups of very small objects, then remember that vector multiple objects or vector single object might make sense for what you're doing. That way, none of the individual objects will ever have a stitch going through the object. Now I'll talk briefly about grayscale. In normal lithography, you generally want the resist to be exposed in a high contrast binary fashion where the different regions are either 100% exposed or not exposed at all. In grayscale, however, you work within a narrow, low contrast region of the resist to make various levels of partial exposure to create three-dimensional features. This only works with positive resists and works better with lower contrast resists. There is a narrow range of doses which provide a fairly linear response. In grayscale, the ML3 writes with 256 levels of gray. In all of the other writing modes, the patterns are designed as a system of coordinates, where if the pattern is drawn as, say, a 2mm box, it always gets written as a 2mm box, no matter what lens you're using. The machine calculates which pixels on the DLP chip to make active to give you the pattern you want, regardless of which lens is used. And for normal lithography, the pattern is always drawn in SNSF format. But in grayscale, your pattern needs to be written in an RGB bitmap file, which is usually in a TIFF format or .bmp format. And since you're writing as individual pixels, the lens that you use is going to change the size of the pixel. Also, the quality that you pick will also change the size of the pixel because of the way the software is set up. Here's an example of the type of pattern you might write with doing grayscale. Then after exposing and developing, you might get something like this with nice three-dimensional features in the surface of the resist. Doing 3D lithography using grayscale is a pretty complicated process, so I'm not going to go into too much more detail on it in this video. There may be times when you actually want to use grayscale, but just use it for doing normal lithography. If your pattern that you want to design is in a bitmap format, then you'll be writing it as pixels rather than as a normal vector type design. So say you're working with a 2D material like small flakes of graphene and you want to make some patterns and align them to those. You can take an image of the flake from the ML3's microscope, taken using yellow LED light, and then export that image into an art program, and then draw contact pads directly onto that yellow image using 255 level blue pixels. Then after resizing that image, you can align to the chip and write that pattern directly onto the chip. The ML3 will only pay attention to the blue portion of the image that you designed. The yellow image in the background will be completely ignored. If you do make a design like that, make sure there's no white in the image. White contains blue, and that means those areas will be exposed. Now let's move on to some of the other features on this machine. I told you earlier about the wide field viewer, which creates a mosaic image of your substrate. You can go up to File and pull down, and you can export the image. This winds up making a huge image because each of the individual images in there that makes it up is a high definition image. So the file will be huge depending on how many images you have stitched together. Also, under this microscope pull down menu, there's a couple different ways you can save an individual image. If you click Snapshot, you get a low definition image, basically what you're seeing on the screen, that doesn't take up too much memory space. Or you can hit Export Image and you'll get the full high definition image saved. If you click on Options, you'll get a little window that pops up that gives you a few options for the microscope. If you make any changes in that, please put them back like they were when you found it, when you're done. In the pull-down menu under Tools, there's a bunch of different things listed. One of them that you may want to use is the Quick Access. When that's checked, this area down in the bottom can have some shortcuts to things that you commonly go to. If you uncheck that, those are going to disappear. Up above, there's an Adjust Calibration. You generally shouldn't be messing with that. And below that is Thickness Guard. That sets a minimum thickness for the wafer. If you're working routinely with thin wafers, this should be probably at 0 or close to 0. If you're working routinely with thicker wafers, then you would want to increase this just to avoid the chance of crashing the lens into the substrate. If you're working with a very thin substrate and you can't seem to get it in focus because it won't let you go far down enough, then you would want to lower this down to 0. Like you might be working with a cover slip, and some previous user may have set it at 500 microns. There's a feature called Surface Profiler, which I haven't actually used much, but what it does is take advantage of the narrow focal range of the highest power lens, and it uses it as an optical profiler. This could probably be pretty useful to somebody working with fairly thick features, like if they have patterned some tall SU8 features and they just want to get a rough estimate of the height of those features without physically touching the substrate with a stylus of a profilometer. Another feature which I haven't actually used is Wafer Inspection. It's a pretty complicated feature where you enter a whole bunch of coordinates, and what it'll do is automatically go to each one of those coordinates and take an image of it. So you can inspect a full wafer and it'll give you a whole series of images in predetermined locations. In the same pull down menu, there's an item Reset XY Stage. This is in case there seems to be some issue with the XY stage not going to the correct positions. This operation takes place normally every time the machine is powered off and powered up again, but it may help save you from having to power it down if you suspect something's wrong with the homing of the XY stage. And the same goes for the Reset Z Stage. This is something that normally happens every time you power up and power down the machine. But if there just seemed to be a problem with the Z stage, this will home it and make sure it's working normally. And this button is for resetting the DLP, which is the digital light processor. Every once in a while, maybe once a year, you'll see a crazy image like this on the microscope view. What this is actually a corner of the DLP chip away from the area with the movable mirrors. If you click the Reset DLP, it'll go back to normal again. Another feature that doesn't get used very often, but it could be handy if you had a bunch of wafers to expose, is that you can set it up to write on multiple wafers. You could take like 4 4-inch wafers and set it up so that it's writing on them all night long. That'd be pretty handy if you're doing real high resolution writes on several full wafers. It'll just go through the whole process automatically. You would set up each wafer separately, and each wafer would have its own name assigned to it. And another obvious feature that's worth pointing out is the slider for setting the brightness of the microscope display. If you put a sample that has something really reflective on it, like an aluminum coating with resist on it, it's going to be blindingly bright, so then you're going to want to turn it down. And on dark samples like silicon or gallium arsenide, you'll probably want to turn it up. These images on the microscope display, by the way, are 3D patterned photoresist that was done using Grayscale. Please note that the descriptions in this video apply to the ML3 software version 3.13.1. Future versions of the software may have minor changes. Thanks for watching.